Here we go. Okay, this is your two-step algebraic equation review for grade 8 prior to starting chapter 10. These are 4 questions you would have seen in grade 7 that has to do with having both a coefficient and a constant and how to isolate variables when there's more than one step. So what you learned in grade 7 is when you have both a coefficient and a constant, in this case we have a coefficient and a constant, the first thing you should always get rid of is reverse to what bedmass is. So if you think of a bedmass would be brackets, then division, multiplication, and finally the last thing you would do was addition, subtraction. Well, in isolating variables, you do it backwards. So the first thing you get rid of is the addition, subtraction. Then you would get rid of division, multiplication. So what that means is you would get rid of your constant first, and then you would get rid of your coefficient. Okay? So if we look here, that means in this first equation, I'm going to get rid of the minus 1 first. And what am I going to do to get rid of a minus 1 constant? I'm going to add 1 to both sides. So we put add 1 to both sides, and I know that those are the opposite operations. So subtracting 1 and adding 1 are like a zero pair. It creates nothing. So what I'd be left with is 2x equals 6, because 5 plus 1 is 6. So that's one step, getting rid of the constant. And the second step comes from now looking at this as another, it's really just a one-step equation now, just a constant. And if I have 2x's and divide it by 2, 2x's divided by 2 would be just an x, because these are opposite operations, multiplying by 2 and dividing by 2. And if I divide this side by 2, I get x equals 3. Now that exact same question can be done without using numbers. It can be using the scale idea. So right here, this negative 1 is really my constant. That's on the side of my variable, and it balances both sides. So this is your constant of minus 1, and we know from our integer experience that if I put 1 there and put 1 there, this equals here is still going to maintain equality. But what happens here is it creates a zero pair. A positive 1 and a negative 1 make 0, just like it did right here. It made nothing. So what I'm left with in my next picture is 2x equals 6. Then if 2x's have the value of 6, what I'm going to do is just draw some mini ones here. Then divide those. So then each x would go on both sides of the scale, and these 6 are going to be equally divided amongst those two scales as well. And what I end up here is a scale, or x on one side, is equal to positive 3. Same answer. In the next equation, I'm going to do the modeling first. So I have, this is my constant. So I'm going to add 4 to this side, because I know there's 4 negatives. 4 positives will create a zero pair. But if I put 4 positives over there, I need 4 positives over here. I'm left with 3x over here and 6 over here. If 3x's are equal to 6, oops, I'll do 3 mini scales. Then if I divide them equally onto 3 mini scales, each of those x's would have a value of 2. And therefore I've ascertained that x is equal to a positive 2. X has a weight or a value of 2. And I could double check that in my next example by substituting. But what we're going to do next is do the exact same thing numerically. The first thing I did was I added 4 to both sides right here. Adding 4 to both sides, I create a zero pair. I'm left with 3x is left over here because this is now gone. And this becomes 6. So I have 3x equals 6, which is what this picture says right here. And if 3x is equal to 6, then if I divide that by 3, which I did right here, I will have 1x equals positive 2. Same answer. Oh, don't know what that was. In the third question, it says x over 2 plus 1 equals 2. Now, most people say x over 2, but technically it's not really that. What this really says is half of x, or x divided by 2. Both interpretations are fair. Half of x, or x divided by 2. So a number divided by 2 plus 1 is equal to 2. So again, we're going to use reverse order of operations. The first thing I'm going to get rid of is my constant. And I'm going to do that by, if it's a positive 1 constant, I'm going to subtract 1 from both sides. I'm left with half of x is equal to 1, because a positive 2 and a negative 1 combine to make 1. Then I'm going to multiply both sides by 2, because x divided by 2, or if I had half of x, if I double that, I'd have all of x, which I'll extend here. So all of x, if I have half of 2 and I double it, I'll have x. But if I double that side, I have to double this side. I have x equals 2. Same thing holds true with the modeling. There's my constant. So if I add a negative 1 to that side and a negative 1 to that side, I'm left with half of x is equal to, all that's left over here is this positive 1 because this is a 0 pair. If I double this side, then I have to double this side, and therefore I'd have x is equal to 2. X is equal to 2. And our last question, we have our variable is on the right-hand side. That's the only difference between the third question and the fourth question. And I'm going to do the modeling first because here's the side that our variable's on. So to get rid of that constant of minus 2, I'm going to add 2 to both sides. And when I do so, I create 0 pairs there. So on the right-hand side, all I'm left with is this third of x, not quite an x, but a third of x. Over here, this created a 0 pair. I'm left with 1. If I triple this side, if I have a third of x, these are the worst thirds ever, but if I triple a third, 3/3 of x would be a full x. And if I triple that side, I have to triple this side. But what I'd be left with is a full x equals 3. Or x equals 3, or 3 equals x. If I go back to my numerical side, my constant's right here. So I'm going to add 2 to both sides to get rid of it, just like I did right here. That creates a 0 pair. I got a third of x is equal to 1, because a positive 2 and a negative 1 make 1. I'm going to triple both sides. And if I triple this side, I have x, because dividing by 3 and multiplying by 3 are opposite. X equals 3, or 3 equals x. Okay? All right, that was a 7-minute video. It's a little bit longer than the other ones. If you like this video, make sure you slap that like button. And make sure you share the video with other people. And hit the bottom, slap the bottom of the page, punch the bottom, punch your brother, bell notification. I don't know what this means. Punch it anyway. All right.